Hi, welcome back to chemistry. My name is Mr. Kubuske. We're starting our next unit today. We're going to be talking about nomenclature. That means like naming compounds. We're going to start with something called binary compounds, which means it's just two types of atoms in the compound. Just simple ones. We're going to start talking about ionic salts today. That'll be the first one. Remember, ionic means is it's a metal and a non-metal bonding together because one is a cation, the metal, and one's an anion, the non-metal. Okay. Now, before we do that, we're going to work on simple ones today. Simple ionic compounds called ionic salts. So, if you could get out your periodic table. Now, if I zoom this in for you, okay. If we zoom in and we pay attention to the metal side over here where hydrogen starts, okay. If you look, I've written some numbers on the top here. This first column, no matter what the element is, hydrogen, lithium, sodium, potassium, etc., okay, no matter which one it is, they all have a charge of +1, meaning that they lose one electron. So at the top, I put a big +1. In the second column, okay, magnesium, calcium, all these guys, okay, they all can lose 2 electrons, giving them all charges of +2. So no matter which one it is in that column, they all have a +2 charge. So I'm going to write that in the top. The same thing goes for the third one over here. Okay, starting at this third column, they all lose 3 electrons, so they get a charge of +3. Now, as I move towards the transition metals, it gets a little more complicated, and we'll talk about those in the second segment. Okay, but if you look at the opposite side, the non-metal side, the same thing occurs as I work away from the noble gases. Remember, the noble gases here cannot receive or lose electrons, so we don't put anything on them. They can't have a charge, so they can't bond with anything. Okay. But that first column before, starting with fluorine and then chlorine and so on, etc., okay, they all have a charge of -1, so I'm going to write that on the top there, okay. The second column, every one of them starting with oxygen and down, okay, they all have a charge of -2, so I put that -2 in the top. Okay, so it's a little cheat sheet for myself as I write right on top of this periodic table. Now, on the other ones, in the transition metals, okay, if you zoom in, like look at manganese here for a second, the Mn, you'll notice that there's lots of little black numbers written on the top of it. It says 2, 3, 4, 6, and 7, number 25 right there in the middle, okay. Those represent the charges that manganese can have. Okay, so we're going to use those again in the second part. But if you would ever come to one, like for example, zinc. Let me show you the zinc real quick. Okay, zinc's an easy one. It's one we'll use a lot. It's number 30 here. But you'll notice there's only one number written above zinc. Okay, the number 2. So that means zinc can only have a charge of +2. So if you would ever not be sure about the charge of a specific element, that's where you would go to look. You'd go on the periodic table. Okay, so let's look at some examples on how to name ionic salts. Now, the reason we always start with ionic salts is that they're really easy to name because you don't have to change much about it. There's no prefixes on either one. Really, the only thing that changes is at the end. Okay, we always put our metal first. And then at the end of our non-metal, we're going to change the ending to "ide." Okay? Doesn't matter which non-metal it is, oxygen, sulfur, chlorine, it doesn't matter. They would all change to an "ide." So it'd be oxide, sulfide, fluoride, bromide, sulfide, chloride. I think I might have said that one, but you kind of get the idea, okay? But nothing changes on the other parts, okay? The metal stays the same, so lithium, for this example, would stay the same, and then the non-metal, the only thing that changes is the ending. So it's just like lithium fluoride, magnesium oxide, and calcium nitride would be examples. Now, how do I write those formulas, though? What exactly does that mean? Okay, well, here's how you do that. The first thing we need to do is we're going to break it apart. We're going to separate the metal and the non-metal, the two different elements here. So I've got lithium as my first one. And let me change colors so you can see. Okay, lithium is my first one, and then fluoride is my second. So I'm going to change those colors and make those different. So Li and F, those are my two. Okay, now the reason I make those different is because one is a metal, which is lithium, so I'm going to put the M underneath here. Okay, and the other is a non-metal. Okay. Now each one of these is going to have a charge. Okay. Now for metals, I always put a little arrow, and you'll learn why we put that arrow here in the second part of the video. But we always put an arrow up to show the charge. So lithium's charge, remember, it's in that first column, so that means it has a charge of +1. Fluorine is in the last column right before noble gases, so that means it's a -1. Okay. Now the next column over, it says Cc above it, and that stands for common charge. Well, the common charge between the two is plus and minus 1, okay? Because what that means is that that's a common number between the two elements, okay? I only need one of each to get to that number. So the formula then would simply be LiF, okay? I don't need any extra lithiums or fluorines to make this compound work. Let's look at the next one. Magnesium oxide, all right? Well, let's separate it out into its parts. Okay, well, there's magnesium, Mg, okay, which is a metal, so it has a charge. And then there's oxygen, okay. Oxide, remember the "ide" comes the ending there. That's a non-metal. Okay, now I figure out their charges. Well, magnesium has a charge of +2 because it's in the second column, and then oxygen has a charge of -2 because it's in the second column before the noble gases. So therefore, my common charge between the two is plus or minus 2. Okay? Now to get to that common charge, how many oxygens do I need? I only need 1. And how many magnesiums do I need? I only need 1. So it's just Mg and O. Simple, right? And let's do 2 more. Calcium nitride. Okay, let's separate it out into its parts. So I've got calcium Ca, which is a metal. With my arrow, it's in the second column. So I'm looking at my periodic table over there. So it's a +2. And then my non-metal is nitrogen, which is in the third column. So it's a -3, and it's a non-metal. Now, my charges don't match. Okay, I've got a +2 and a -3. How am I going to make this work? What's my common charge going to be? Well, really, it becomes the lowest common denominator. Okay, if that's still too complicated, if you don't quite know how to do the math, there's a really easy way to do it. Okay, all you need to do is start adding numbers. Okay, so let's add a calcium. Okay, let's add one more calcium. So let's put another +2. So now I have a 4 plus 4 and a 3. Does that work? Nope. So let's add one to the other side. Okay. Now I've got a +4 and a -6. Does that work? No, that doesn't work. So let's add another calcium. Okay, now I have +6 and I have a -6. So I actually wrote the extra charges. Each one of those charges represents another calcium that I'm going to add or another nitrogen that I'm going to add. So the common charge between them, the lowest number they can both get to, is plus or minus 6. Well, since I had to add calciums and nitrogens in order to get to that number, okay, I need to show that when I write my formula. So it'll be Ca, and then I need to show how many calciums there were. It's Ca3, okay, because I needed 1, 2, 3 calciums to get to a +6. How many nitrogens do I need to get to a -6? I need 2, so I put N2. So it's Ca3N2 for calcium nitride. Now, you wouldn't know the numbers just by looking at the name. Okay, that's why we have to figure out the charges when we go to do this. Okay, let's do one more. Let's work the opposite direction. Okay, I have K2O, so I'm going to just separate those out. There's O, which is non-metal. That's a -2. And then there's K, which is a metal. Show its charge, which is a +1. Okay, now since I have 2 Ks, now it's already done the work for me, so I just put another +1. Okay, so now my charges have already equaled out. Okay, that's the nice thing about doing it this direction. So my common charge is plus or minus 2. Okay, and then do I do anything fancy to the name? No, I just write it as it sounds. Potassium, and I'm sorry I have my back to the camera. I know you're not supposed to do that. Potassium, not oxygen. How do I change it? That's right, I change it to oxide. Okay, potassium oxide. That's how you do ionic salts. Okay. Now, in the second part of the film, I'll show you how to do this when we have multiple charges. Okay.